Hi everybody, welcome to my workbench again on our next part of this video. Well guys, you missed the testing. It was my intention to let you in on that, but unfortunately I didn't push the button correctly, so the camera wasn't on. So I was talking to myself, really. Anyway, it was not very nice anyway. Well, to make it long story short, I tested those 2 meters. They were initially working, so went nicely up to the voltage was up here. That's about 350 volts. Anyway guys, when I put the valve in, I'll show you, it's this one here. I tried that one. Then my anode voltmeter went to 0. Absolutely nothing. I thought, well, that's odd. And looking for it and see what's going on. And then as we saw it, smoke. This resistor here is absolutely blackened. If he goes, he goes. But unfortunately, he took the diode with him, and also he took our MOSFET and my stabilizer Zener diode with him. The other thing what I discovered, I could have prevented that by making the figures, do the math. I should have known that those resistors 10K were too big anyway. So this one is working, gives me about 150 volts. If you know that's 350 volts, then you know a lot of that is gone. So what I'm going to do next is, I will show you. I have that here. I lost a moment. Yeah. Okay. I have another resistor, 820 ohms, so I will place them. For them, there's 2 watts. And I have another MOSFET here. We can put that in. So we have the diodes. I have some spares there, so that is not that bad anyway. So, but then again, you have to take it all apart again to start all over. So yeah. Oh yeah, didn't show you what was the short. It was a tiny sliver. What this was between. If you have to, I don't know if you can see. Try to let you. This is 9 and 8. A tiny sliver. That's the wrong side. Sorry. It was a tiny sliver between those 2 contacts was making the short. So I had to actually pull the screwdriver through it, otherwise I wouldn't have found it. So tiny, so small. So if the valve was out, well, there was no short. Put the valve in, you have the short. Then you have to find out where is it. So and by the time I did find it, then this resistor was going up in smoke, so it doesn't really matter, but then again, it is a nuisance when it happens. So anyway guys, you have to be aware when you build something, and you see that often by other radio amateurs or people who repair radios, when they make something, build something, an amplifier or whatever, then they all do the smoke test. Well, in actual fact, I've done that to make the smoke, and I was successful. I created smoke. So only unfortunately you didn't catch it because I didn't put on the camera. Anyway, now another thing that I discovered, that my power supply here is also not working well. So without the valve in there, we have a nice voltage here. Not the voltage I want though. That should be 6 volts, but it says 18 volts or something like that. When my potentiometer of the VR should be able to correct that. It's not working, so I probably made a mistake there as well. So that is possible. I'm a human, so I make mistakes, unfortunately. So that's another thing I have to address. So what I'm going to do next now is to get those resistors of the VRs, get that wire off, get that wire off, get this wire off, and then again pull it out, and then we'll suck off the soldering, and get the parts out who are damaged or broken, whatever you call it, and replace them. And if I do everything right, that is, then it should work. Anyway, so well, I think it is always rather inspiring that something happens like that. That you always have to put you on your toes, really. Because if you get complacent, you make stupid mistakes. So, well, I'll let it on to you what you think it is. Anyway, guys, next thing I'm going to do is, as I told you, I'm going to remove the print again and make all the wires loose and get the faulty parts off. You put no new parts on there, and with a download check everything is alright. See what is wrong with this one here. I can pull up the schematic. I had that schematic somewhere, I can't remember where. Anyway, I can do it from memory, but I'm 77 years old. My memory isn't that good anymore, so I have to refer to well, the facts. Actually, I have to put it that way, because you find the original schematic and see where I went wrong. The possibility is the resistor is here, that he is too small or too big, I don't know, and this potentiometer or VR is the wrong one. It should be 4.7 K. Let's have a look if that is the case. Stupidly, it wouldn't surprise me if I done that wrong as well. So let's have a look. Find out. You can see. Oh dear. 6. Yeah, you can measure other things. I think he's 4.7 K, so that should be okay. The problem is then this resistor here is not the right one, so I didn't pay attention here, I suppose. But anyway, guys, so far so good. I will shut down the video, because if I'm going to do that on camera, that will be that video will be ever so long. So anyway, if you are interested to see in the future how I do things, then let me know. Just put it in the comments and let me know what you want to see, and that would be easier for me and nicer for you if you can see a video what you like. Okay, so guys, I will shut down the video now and I'll come back to you, okay? Hello everybody, welcome back to my workbench. Well guys, as I mean, hours and hours and hours and hours I've been busy on this valve tester. But last but not least, we got where we want to be. We have our negative voltage at 6 volts, we have our meters working, so I'm going to show you. What I want to tell you first is I have here the EL84, and there's another one, EL84. This one is the good one, and this one is a bit less, less emission that I'm on. So what I want to show you is if I look at my tube book, EL84, you can see here the black spots on the foot. They are internal connections. So there's another point, because I did some studying, and that's how I discovered it. That they were connected, and it's causing a short if your switches are not right. anyway, number 1 should be equal on number 2. That's the entrance grid. Then you got the number 5 on the heater, on the filament. Then you have the number, have a look, the number 7, that's that one, but that is the anode, and the number 9 on the screen grid, and we have 8, there's an internal connection, has to be on the same spot. If I put the number 8 on this for instance, off, then I have caused myself a short. So anyway guys, I'm going to show you now that the thing works. Yeah, so I'll put up our voltages. See, he's working. This one is working as well. So we're going to put that down like that. He's on 100 milliamps. That is 10 milliamps. That's 100 milliamps. Then this one is on. I'll put this off. This filament's off. This is 5 volts. This is 6.3, and the valves are 6.3. So I'll switch off for a minute. I'm going to put the good valve in there. There we go. When the valve heats up, then you see this, you should read this as milliamps, and this you should read as volts, okay? So we put that down, just let the valve heat up for a minute. I will put this on approximately 250 volts, about right, and this I put on approximately at 140 volts. Yeah. So just let the meter up. Then we see the meter come up. The maximum milliamps it should draw is about 38 milliamps. Then the emission is good. See, I didn't put my negative voltage right yet, so this is 1, 1.5, 2, 3.5, 4. About 4 meters, that's about 4 volts. So I put I couldn't go further than that far. That's it, about 150 volts. See, it's 38. I won't exceed the maximum current. I won't do that. So what I want to show you, you can see the amplification factor. Up. Big mouth. Look at this, I've done wrong. The voltage is too high. Probably. I don't know. So let's try that again. Ah, that's odd. That's odd. I tried it before, so let's have a look what I've done differently then. Hold on guys, I have to look. You have to go to the right adjustment, so otherwise it won't work. Yeah, that he's responding now. So we get a bit further down. At 20 milliamps. Have a look. It goes up and it goes down, and that's the difference from your application factor. So it's about 80 milliamps. Up is about say 5 milliamps on amplification factor. What he tells me. I don't know if the settings are right, you know. So I have to figure it out further for me also. So there you can see it, the thing works. I will leave the setting like that, which you saw it working, yeah. Down, up. See it. I'll go back to 20 milliamps. Try it again. Up, down. Yeah, the valves have a long time been used, so there's a possibility that they have some gas or anything in there, so that it hampers the functioning. So there's a possibility. What you actually should do is leave them on for quite a while, so they can heat up really well, and then the gases will disappear. So sometimes that happens. If in a valve long time it's not been used, then it can happen, you know. Anyway, you can see it again. Go up and go down. So that's the amplification factor. I can try even less than that. So let's try about 10 milliamps. So see what happens there. Okay. Put about 10 milliamps now, and we'll try that again. Now the difference is smaller, you know. You have to go up. So put it up to 30 milliamps. See what happens there. Okay. One up, goes down. Say you got 23, and that's 20 milliamps seems to be the best bet. But we have a point here. Yeah, you can see the amplification factor. So I keep them at 20 milliamps. But you have to adjustments. But you can see the difference between doing this. I put the pull them out, I'll switch up. Don't switch them off, so it's quite hot. Don't burn your fingers. Let's put this one in. There we go, just watch the milliamp meters. You should be about the same on emission. If you have the same emission, then it should be on 20, you know, 20 milliamps. If you goes below that, yeah, then we know something is wrong with that valve, or wrong. You know, he's not that good. You see the difference? There is a difference. Not a lot, but there is a difference. It's the same thing counts for this one. Goes for this one. If you leave them long on, the probably gases will be in there. Yeah, it's a bit less than the other one. So it's a bit, will need 1 milliamp less. It's quite a good valve though. Let's have a look up. Now, the amplification factor is not the same. That's for sure. But you know, you can see the emission slowly comes up, so we don't know. That's quite a good valve actually. There's nothing wrong with that valve anyway. But it is a nice way to show you how things work. So you have your anode, you have your screen grip. Screen grip has about approximately 120 volts, and let's go back here a bit. It shouldn't exceed 250 volts. It shouldn't exceed that. So that's about. It should be about 210 volts screen grip. There is no resistor in the cathode, so if I would do that, the current will go up, and probably I would damage the valve. Let's see. Have a look. If we go up, it drops down. Yeah, 22, nearly 22, and 17, something like that. 25 to 5, and in the book this is 10 milliamps, probably right. See, it's about half. I measured the half of it, so that's a bit. There again, guys, I have to figure that myself, so I'm not lying about that. But anyway, I had the idea to build this this set. Well, what we could do is switch them off. Yeah, I have another 2 valves handy, so I will turn everything back down. Okay, I've buttoned everything down. So we're going to get another valve. That is an EL. I didn't test them yet. I don't know anything about that. EL95. So it will fit in the small socket here. There we go. Now have a look at always the highest number will be the filament. EL95, I have that here. Filament is 4. Up again. That is 4. The anode is 5. That's this one. On back. That's 5. 6 is the screen grid. 1, 2. That's screen grid. And the G1 or the entrance grid is 1 or 7. I will take 7. That's 7, and that's fine. There are no internal connections, you can see, and it should be at 5 milliamps. So probably we'll read the half of it. Experience. Put them on. Let's see what the voltage should be on. Again, there are no resistors, so the voltage should be 250, both of them. 250 volts. Put them up. Okay, there's no voltage here. Okay. Is he on? He is on. Let's have a look. 1 volt. Okay. We've done something wrong. Let's switch off for a minute. We've done something wrong here. Looks like a short. So again. I have to figure that out. 250 is 5, is that one. That is filament, that is anode. 6, that is screen grid. That's what? That's screen grid. And 1, I have to put that on 7, I'll put that back. Oh, there. Should be that one. Huh? Try it again, guys. I made a mistake in my switch. Keep them on. It should be max for our anode 24 milliamps. So we have exceeded that already. With the max at 24. So let's keep them on 20, what we've done before, yeah? Put them on 6. Let's see what happens here. That doesn't work that way, so we have to put in 250 volts again. Get them down to 10. Nearly 10, see what happens now. Can't find anything. Doesn't react. And that's 7. Okay, hold on. Let's see what I've done. I need 1 and 7 at the same setting. That's what I need. I need 1, otherwise I have a short. Yeah? So I put 250 volts, put them up to, what should it be? No, to 250 volts. I wouldn't do that. See what happens now. See how it reacts. Okay. So that is working. Okay. Okay guys, that is about it to show you, and yeah, I think it is a success, I would say, and hope you enjoyed the video and let me know if you like it. So I'll see you then on the next video, okay?